In this video, we are going to discuss about log amplifier. So here, for the inverting amplifier, instead of this feedback resistors, I'm going to replace it with by a diode. Okay. So diode D1. So the voltage across this one is VF. Okay. Here you can see the non-inverting terminal is grounded. Okay, so the current flowing through this one is I1. So this one is also I1 because the current flowing through this one is 0. Okay, so on this point is it's virtually grounded because it is 0. So I can write the equation for the current, right? IF is equal to here it is I1, and that is equal to IS e power VF, the voltage across this diode, divided by KTQ. Okay, and so the value of KT by Q, right? KT by Q is nothing but 25 millivolts. Where Q is my electron charge, VF is nothing but forward bias voltage. K is a Boltzmann constant and T is absolute temperature, which is measured in Kelvin. Okay, so the VF value is approximately which is less than 0.6, and therefore the IF value is less than 1 milliamps. Okay.
Not bad.
So from this equation, I can write I1 by IS is equal to e power Q VF divided by KT. So if I take ln on both sides, I will get VF by 26 milliwatt. Okay. So therefore I can write VF is equal to 25 or 26, okay. 25 millivolt into ln IF by I1 by IS. Okay. So this I1 is equal to I1. So I can write I as V by R, right? V1 minus 0 divided by R1. So I can write I1 as V1 by R. So 25 millivolt is equal to ln V1 by IS R or 1. Okay. So here you can see my
Wow, we here got a great ad to go ahead and
and from this equation, from this path, I can write 0 minus V0. 0 minus V0. Okay, 0 minus V0. That is equal to VF, right? 0 minus V0, that is equal to the voltage across this one. That is nothing but VF. So I can write VF is equal to minus V0. So substitute in this equation. So I can write minus V0. So V0 is equal to minus 25 millivolt ln V1 divided by IS RS R1. So you can see my output voltage is logarithmic value of my input voltage. Okay, and you can see it is inverted since it is given to a inverting terminal of my input is given to the inverting terminal of my opamp. Okay. So let me discuss one problem on this logarithmic amplifier. So the first problem is it is given that R1 value is equal to 47K and IS, okay, IS value is equal to 25 nanoampere. Input V1 is equal to 1 volt. Find V0. So this is the question. So we know that V0 is equal to minus 25 millivolt ln of V1. V1 is V1 divided by ISR R1, right? So this is a formula. So you have to substitute this value 25 milli ln 1 divided by IS is 25 into 10 power minus 9 into 47 into 10 power 3. So if you substitute this value, you will get the answer as minus 169 millivolt. This is the value of V0. Okay. See this entire circuit, instead of the diode, I can replace it by a transistor. Okay. So here you can see the collector is collector and the base is grounded, right? Because you can see that this is the collector part that is grounded. Or it may be a base. Base is grounded and the collector is connected to the virtual ground. Okay. So you can see this VB is since base and collector is grounded, this will act as a diode. Okay. And it has a voltage drop of VB, right? So the VB value is 0.7 or less than 0.6. Okay. So here the IS value will represent nothing but IEBO. So it is nothing but a reverse saturation current.
On the area, I would draw that high to
And this current it varies with temperature, right? So therefore temperature compensation
that it in it.
is required.
It's only not on A and like that.
Okay.
They like hate is
Next, let me explain anti-log amplifier. So here you can see the diode is connected at the R1 instead of this RF. Okay.
in thought we got the bed. That go. When no I'm not in the Indias and those out hello and about I got the devil. Because I got stuff that they did it out, they got him in it and it being Sunday out in the way including anyone going on without. They would up.
So let me explain this current is IF. Okay. So I can write the IF current that is equal to IF current. So I can write
And yeah, in there. Hey, that I need about and going by and base.
0 minus V0 that is equal to IF R1. The current flowing through this one is IF, right? 0 minus V0 is equal to IF RF. So I can write V0 is equal to minus IF RF R1. So what is the value of IF? IF, you know that IF is equal to IS e power QVF divided by KT. right? So I can substitute e power q vf by kt r1, right? So this I can write it as minus is r1 e power q vf by kt. I can write it as anti-log of
extensive value about on the Yuan and or any and make the
vf by kt by q, right? So what is kt by q? Kt by q is nothing but 26 millivolt, right? So what is vf? Vf is here, vf is nothing but v1 minus 0, that is equal to vf. So I can write v1 is equal to vf, right? v1 minus 0 is equal to vf. So I can, instead of vf, I can write it as minus is r1 anti-log of v1 divided by 26 milliamp.
I'm at on the map and the little bit.
So here I can replace this diode by a transistor, right?
Only in London.
So you know that so instead of IS, I have to use IEBO, and the voltage drop across, since this collector and the base are grounded, it is act as a diode, and it is having a voltage drop of VBE. Okay. So based on this, I can solve one problem. Given the R1 value is equal to 47K and IS is equal to 25 nano ampere, and V1 is equal to 169 millivolt, and what is the value of V0? So what is the formula? V0 is equal to minus IS R1 anti-log of V1 divided by 25 millivolt. So if we substitute, we will get
You will already made beauty need that shit.
anti-log of 169 millivolt divided by 25 reading. So if we solve, we will get the answer as minus 1.
Or in the end, all in was.
So I hope this video is useful.